Good morning, student. Today we are going to learn about SRAM, static RAM. After the completion of today's session, you are able to draw the diagram of 6 transistor SRAM and explain the operation of SRAM. So, SRAM full form is static random access memory. So let's go to the diagram. This one is the diagram, consists of 6 transistor, means 1 2 3 4 5. Okay, so this part is the memory part. Here we use 2 inverter back to back, means if we use NOT gate, then it looks like this. Okay, this internal part is look like this. Here 2 inverters are connected back to back. So if here we give 1, then here we get 0, then again in the output of second inverter we get 1, means this is in a loop and the input given is stored here. So we can say if here it is Q, then it is Q bar. So always here we get 1 and here 0. Like this, if here we give 0, then at the output of first inverter we get 1, then at the output of the second inverter we get 0, means here we always get 0 and here we always get 1. So Q equal to 1, Q equal to 0 and Q bar equal to 1. Like this it stored the data. Next, see here, this one is the diagram of SRAM, consists of 6 transistor. These are 2 columns. Name of the columns are bit line C and bit line C complement. So simply we can say this one is the bit line and this one is the bit bar line. Okay, and these are 2 transistors used to charge these 2 capacitors. Okay, so always before any operation we charge these 2 capacitors. Okay, and that operation is known as pre-charge operation. Okay, and M3 and M4 are known as access transistor, and these outputs are connected to access transistor for read and write. So which output, means when we discuss about that inverters are connected back to back, there we have 2 output Q and Q bar. So this point is Q where 1 is written and this point is Q bar where 2 is written. So Q means one output, Q bar is the other output. These outputs are connected to these access transistors for read and write operation. Okay, then this one is the word line. Whenever the word line is 1, that means we can do read or write as per required. When it is 0, then it hold the previous data. Okay, then this bit line and bit bar line act as input line for write operation and output line for read operation. Okay, and pre-charge capacitors are used for read and write operation. These are the pre-charge capacitors. Okay, so next we see how read operation and write operations occur. Okay, next, here this one is the diagram for read 0 operation. Okay, read 0 means initially we assume that q equal to 0 and q bar equal to 1. Okay, q equal to 0 means q is stored in this memory, so in read operation we read that data. And for read operation, first we have to activate this word line. Activate means we activate by giving 1. Okay, so when we activate this line, M3 and M4 are turned on. So here you can see after activating the word line, M3 and M4 are turned on, and these transistors are known as access transistor. Okay, then these capacitors are pre-charged, so it is fully charged. Then as this is a read operation, so bit and bit bar line, these lines are this column, bit and bit bar lines are act as output line. Okay, so when the capacitors are fully charged, that means these nodes are having high voltage, means at logic 1 level. So we can say it is nearly equal to VDD value, means 1, equal to 1. These nodes are at logic 1 level, and these nodes means initially we assume that q equal to 0, so it is in logic 0 level, and this one is the q bar point, so it is at logic 1 level. So when q equal to 0 and this point is at logic high level, then there will be a voltage difference present. Because of that, this capacitor starts to discharge. Okay, so when it is discharged, the voltage of this point starts to increase, but here we have to maintain the voltage of this point always below the threshold voltage of M2, so that the M2 never turned on, to maintain the read operation and the stored data never destroyed. If it increases the voltage beyond the threshold voltage of M2, then the stored data is destroyed. Okay, so we have to maintain the value. So remember that when it starts to discharge, the Q value never exceed, okay, all means always less than VTN, threshold voltage of M2. So this Q point we can say, or we can denote it as V1. So V1 is always less than VTN. Okay, only by maintaining this condition we can keep the data safe, whatever stored in this memory. Okay, so when the capacitor starts to discharge, the value of this node or value of this column starts to decrease. But here this node is at logic 1 level, and this node, that is Q bar node, is also at logic high level, so there is no change occurs. Okay, only at bit column the voltage starts to decrease, and that decrease of bit column interpreted as read 0 operation. Okay, so let's discuss about read 1 operation, then it will be easier for you to understand. Okay, read 1 operation. For that, initially we assume q equal to 1 and Q bar equal to 0. So this one node is 1 and this 2 node is maintained at 0. And before read operation we have to pre-charge these two capacitors. So due to pre-charge of these two capacitors, these two nodes are always at high level, means 1. So see, and for any operation we have to activate the word line, always remember that. Okay, due to activation of word line, M3 and M4 are turned on. See here, when we see this part here, the Q equal to 1 and this voltage node is also 1, so there is no voltage difference present. Because of that, there is no current flows and no voltage change occurs. Then here we have to see, here this node is at 1 and this Q bar point is at 0 level. So here a voltage difference is present. Due to this voltage difference, the current starts to flow in this direction, means the capacitor starts to discharge, and because of that the bit bar column, as we consider it as bit bar line, okay, so voltage of bit bar column starts to decrease, and this bit bar column decrease process is interpreted as read one operation. Okay, so this is all about read operation. So for read one operation, this point is 1 and this point value is 0. So because of one value, the M1 is turned on and M6 is turned off, and the Q bar point is at 0 level. So because of that, the M1 is turned off and M5 is turned on. Okay, so for read one operation, M6 and M1 are in off condition and M5 and M2 are in on condition for the operation, and M3 and M4 are also in on condition due to activation of word line. And for read 0, M6 and M1 are in on condition and M5 just opposite of read 1. So M5 and M2 are in off condition. Okay, so it is all about read operation. Next we discuss about the write 0 operation. Means we have to assume that initially in the memory cell 1 is stored. Okay, 1 is stored means Q equal to 1 and Q bar equal to 0. So this point is 1 and this node point is 0. When Q equal to 1, that means M2 is turned on and M6 is turned off, and when this node voltage is at 0 level, that means M1 is in off condition and M5 is in on condition. As we know, when we give 1, then NMOS is turned on, and when we give 0 at its gate, then PMOS is turned on. The same logic is applied here. So this one we initially assume that logic 1 is stored in this memory cell. So when we try to write or change the value, first we have to activate the word line. So when we activate the word line, at that time M3 and M4 turned on. So this point is at 1 and this point is at 0, and we have to grounded this column voltage, that is bit column voltage. So we make the voltage to 0 volt of this bit line. So because of that, this node voltage is at 0, and here it is 1 and here it is 0, so there is a voltage difference present. So here the current starts to flow. Because of that, the node voltage starts to decrease, and here the value is at 1 because we do the pre-charge operation. So this node voltage is at 1 level, and we assume that Q bar is at 1, so there is no voltage difference present, so there is no change occur. But when here the voltage starts to decrease, then gradually the node voltage, this internal node voltage, we can say this internal node voltage becomes below the threshold voltage of M2. Okay, VTN decreases how much? Na V1 is less than VTN. Okay, when V1 less than VTN condition occurs, then M2 is turned off. Okay, when M2 turned off, then it assumes that we write our data in the memory cell. Means initially it is 1, and when the voltage starts to decrease, here the voltage becomes 0. So our process completed and the write operations is also successfully completed. Okay, next we can also discuss about the write one operation for better understanding. Okay, so for write one operation, we have to assume that the memory cell contains logic 0, means Q equal to 0 and Q bar equal to 1. So when this node voltage is at 0 level and this one is at 1 level, that means 0 means M6 is on and M2 is off, and here this one means M1 is on and M5 is off. And here we grounded the bit bar column, means this line is at 0 volt. So when this point is at 1 and this node voltage is at 0, then current starts to flow. So gradually this high level voltage level starts to decrease. When it is decreases from the threshold voltage of M1, then M1 is turned off, and within that time here the value is 0 and here the charge of the capacitor is high, that means this node voltage is at 1 level. So here also a voltage difference is present, so current starts to flow, and gradually the voltage of this node starts to increase, and when it exceeds the voltage threshold voltage of M2, then M2 is turned on. Okay, this one is turned on. So when M1 is off and M2 is on, that means it is interpreted as Q equal to 1, means write operation successfully completed, means at the output we see Q equal to 1 and Q bar equal to 0, as the M1 is turned off and M2 is turned on. Okay, so this is all about SRAM. Thank you.